Hey class, Mr. Houston here. Today talking about Chapter 4. We're combining lessons 7 and 8 on congruent, isosceles, and equilateral triangles. We're going to use these to prove some theorems, and so that way we can still figure out angle measures, all that other stuff that we've been doing along the way. So the very first thing, we'll start with example number 1. Use congruent triangles. So explain how you can prove, or you can use the information given to prove that the hang glider parts are congruent. So we're going to go ahead and we're going to mark the information that we know. So we know angle 1 is congruent to angle 2. So we'll mark that here. And we know that RTQ, so this angle here, is congruent to RTS, is right here. So we have two angles that we know are congruent. So we need a third piece of information to prove one of our congruence theorems, or one of our postulates. And the easiest one, the one that's always I like to find, is this one right here. It's overlapping, right? That's overlapping. So I could say RT is congruent to RT, and that is by the reflexive property. So then, because I have enough information there, I can say triangle QRT is congruent to triangle SRT. And I know that because of the angle side theorem. So AAS allows me to say that the two triangles are congruent. Now they wanted us to prove that QT is congruent to ST. And how we do that is another theorem. It's not on here, but it's CPCTC. And what that stands for is congruent parts of congruent triangles are congruent. So once I can prove that the two triangles are congruent, so in this statement right here, okay, by doing the angle side, now I can say that anytime I have corresponding parts, in this case it was QT, so this line, this piece right here, nope, I don't want that, this piece right here, and this piece right here, they are congruent because once I've proven the triangles are congruent, all the corresponding parts are congruent. Okay, so that's something I would definitely write down, circle, highlight. Again, it's corresponding parts of congruent triangles are congruent. You can see now why we abbreviated out CPCTC. Okay? Alright, let's move on to a couple theorems here. First theorem is known as the base angles theorem. So if we, in a triangle, anytime that you have two sides of a triangle that are congruent, then the angles opposite them are congruent. So I know that AB and AC are congruent, so opposite them, like this, C would be congruent to B. Okay? So the converse of that is that if I have two congruent angles, then the sides opposite them would then be congruent. So AB and AC, just so you know, so those work that way. So if I'm looking at example 2, they want us to name two congruent angles. So if I have a mark here and a mark here, we'll draw it to the opposite, and we could simply say that angle F is congruent to angle E. Another way to look at it is that if they are congruent, then it's the angle that they don't share. So D would not be it. It'd have to be E and F. Okay? All right, flip over to the other to the side. So let's take a look here at these corollaries. Corollaries is just basically stuff that we don't really need to prove. It's just the way it works. The first corollary is the if a triangle is equilateral, then it's equiangular. So think about if we had two sides that were the same, the opposite angles were the same. Now we have three sides. That means the three angles have to be the same. And then the converse of that, if I have 3 equal angles, then I have 3 equal sides. All right, so let's apply that here to example number 3. Find the measures of angle P, Q, and R. So because the sides are all marked, that means the angles are all the same. So we'll just call this angle X. So I have X plus X plus X equal to 180 degrees. Don't forget, triangle adds to 180 degrees. 3 x's together gives me 3x. Divide by 3. X is going to equal 60 degrees. So each angle measure in here would be 60 degrees. This would be 60, this would be 60, this would be 60. All right, so that's how we use those corollaries. So then we're going to use our corollaries and our other stuff to find x and y in this particular diagram. So the first thing I would always do, now that we know all this information, is whenever I see something, mark it down. Make sure that we know if it's congruent, if it's not congruent, if it looks congruent. We don't care if it looks congruent, we need to be able to prove that it's congruent. So the first thing I will go and do is I'll look at my congruent angles, and if they're all 3 congruent, then that to me means that all these sides are then congruent. Okay, so notice that all those sides are congruent. Then if I come here, I have base angles, and the sides opposite them are congruent. So actually, all 4 of these sides are congruent. So the easy one here is find the value of y. Y in this case is just going to be 4. This part right here is 4, so then this would have to be 4 as well. X we're actually going to have to solve for. So we know that x plus 1 equals 4. So you subtract 1 on both sides, you get x equal to 3. So in this case, y is 4, x is 3. So that's a little bit about congruent, isosceles, and equilateral triangles. Hopefully we're picking up some more of these triangular things. Remember, everything adds to 180 in a triangle, but hopefully you're starting to pick up where we can find some information, especially when they're equal or or equilateral or isosceles, or just doing corresponding parts of congruent triangles. So that's all I have for you today. If you have any questions, bring them with you to class, and we will see you then.